Alright, in this video we're going to also take the integral, and instead of doing the integration by parts, we're going to do the integration by parts by using the table. So once again, you have to select a u and a dv. So in this problem I'm going to select u, and I'm going to say that's equal to the cosine of x. So I'm going to put that over in the derivative section. And then I'm just going to take the derivative several times here. And of course the derivative of cosine is negative sine of x. And the derivative of sine of x is cosine of x. But I have a negative sign out there, so I have to keep it. And I'm not sure if I'm going to need to do it a fourth time, but you know, the derivative of cosine is negative, so negative times negative gives me a positive sine of x. Alright, in this problem we're going to pay particular attention to the initial integral, because it's going to become important, because this thing just keeps oscillating, and e to the x, if we choose that as dv, and we'll do this one in red, choose that as dv, that would be dv is e to the x dx. So we have our e to the x. You notice that this thing just stays the same, right? If you take the integral of e to the x, it's just e to the x. Take the integral again, it's just e to the x. And you're getting nowhere fast, right? So let's just continue with this table and see if we see something interesting. And this is our plus minus sign, right? Plus minus column. Start off with a plus. Let's see, let's erase that. Alright, so remember the step is to connect the diagonals of these two entries. And we notice something. Let's see, we have the first step is a plus sign. Then the second term is going to be minus, and then we have a plus again, right? And minus if we need it. But if we look at if we build this thing, let me show you here. We have e to the x, cosine of x, and then in the second entry we have these two terms being combined together, which would be minus minus, right? So we have minus minus, which is a positive, e to the x sine of x. And then if we look at the last two, I'll try to highlight this in yellow. If we look at these two, this one's going to be a plus, but we have a minus sign out in front of there. But you notice that here, these two terms are what the original integral is, right? So it's exactly what this guy is. So when that happens, what we do is we just simply rewrite it like this. We say, well, that's a minus the integral of e to the x cosine of x. So if we continue this process, this thing's just going to keep repeating itself over and over and over. So what does all this equal right here? This is equal to the original integral, which is e to the x cosine of x, right? Okay. So notice here that if we sort of treat this like an algebra problem, if we add this e to the x cosine of x to both sides of the equation, we have two of them, right? So let me see if I can rewrite this over here. Running out of space, I'm going to erase this part right here. So we have 2 integral e to the x cosine of x is equal to e to the x cosine of x plus e to the x sine of x. Well, the integral is what we're trying to solve for, so to get rid of this 2 times, we just divide both sides by 2. So the integral of this whole thing is just equal to 1/2 of the quantity e to the x cosine of x plus e to the x sine of x. So you can use the table on this, or if you just use integration by parts, you'll notice that anytime you write the integral and it in the integration by parts section, and it is the original integral, then you have you can combine those terms just like an algebra equation.